As we know, right, Kafka is a messaging system. So, what and all it can do for us, let's understand that no, first. In reality, messaging is a hugely important piece of infrastructure, right? So, for moving data between different systems, if you see in this diagram, right, so I have, different source systems as well as different target systems. Now, suppose I want to, move data from each source system to each target system, depending upon the volume of data or complexity of data we are actually pushing from one to another, right? So this will give a lot of load into the entire infrastructure, right? So because of some couple of reasons here, right? So if you see three source system and three target system, right? So in this tree only you will get 9 integration points. Okay, suppose you don't have any messaging system in place and we want to access the target systems using APIs. So at least minimum, we'll get 3 into 3, 9 integration points. So you have to actually implement and handle all these integrations, right? Then there might be different protocols, for each source as well as a target systems. So we have to also look into that part, like how we can support different protocols, then different data formats. One system may have a raw JSON file, one system may have raw CSV file, one system may have raw text file, or one system can have only images, right? So we have to cater all these different data formats also, right? Again, when we transfer data from source to destination, right? So we also need to think of like what is the data schema of we have to actually use in the target systems, right? So without the schema defined, we will not be able to send the data because data has to go and sit somewhere, right? So in a predefined space with a predefined format. So we have to also think about the schemas, and then most importantly, we have to think about the performance of the entire system, right? So if we need like one-on-one communication between all the systems, obviously the performance will be low because it will give lot of load in the in your communication mechanism or the way you are actually sending the data, right? So we have to consider all these challenges, while transferring data from one system to another system, right? So let's see the image one more time, right? So we are introducing one new layer here, so that is called Kafka. So Kafka will actually take away all the complexities whatever we have mentioned in the previous diagram. Okay, so the target system and the source systems will be completely decoupled here. They can send messages with each, for any system to any target, destination. We can send the data, and interestingly, like suppose you want to send data to multiple target system, that is also possible here, and that is performance wise also Kafka is very very good, like so we'll see here with some real-time things, like where we really use Kafka. For example, your website is producing some real-time events, right? So and you want to send those events to some databases or your email server or your analytics systems, right? So you can use Kafka there, like or maybe the pricing data, transactions, right? So real-time transactions. Mostly, Kafka is actually used in real time when you want to transfer real-time data from one system to another system, basically. Okay. So let's see, some of the advantages here. Why what can where exactly can Kafka help, basically. Okay, so yeah, this is fully distributed, and it provides resilience architecture and fault tolerance. We will talk about it, how actually Kafka can provide this kind of architecture. Then it can scale horizontally. You can actually create multiple brokers here inside your Kafka pipeline. We'll see what is a broker in a upcoming slides. Basically, you can scale to millions of messages per second. Okay, so scaling is easy here. Then again, performance is good. And you really get real time high performance here. And yeah, as this data says, right, a lot of companies are actually using Kafka. I'm just putting some name, but yeah, a lot of companies are actually using Kafka, leveraging its advantages to get, to transfer data from, real time data, basically from source to systems. So this is a publisher and consumer model here. So as I think we discussed a little bit about PubSub model before. So if you see in MQTT, right, so there it is actually a push, basically, the broker will push the messages to the relevant, destinations or whoever is subscribed for. But here the consumers has to actually pull the data from the Kafka. So that is the difference between Kafka and MQTT. So okay, so these are some real time use cases. You can see Kafka we can use in messaging system. Okay, we can use activity tracking systems like Uber, for example, right? So you want to track your different location of your drivers or cars, right, or users. So real time tracking is easy using Kafka. Then you can use in analytics, basically, suppose you want to get some data from some sources like Facebook, Twitter and all, right? So user specific real-time data. So you can very well use Kafka in that case, like to pull the data from different sources, and then use that data for machine learning and analytics purpose. Then yeah, logging is another use case for Kafka. Like it helps to gather logs from different systems, because we know, right? So logging is again a different system produces different kinds of logs. So suppose you want to consolidate all those logs and then create a single logging kind of system. So you can use Kafka here. Stream processing, again, for example, the same Twitter example, right? So data will be coming in real time. So in that case, the volume will be high and the frequency will be high, right? So Kafka supports stream processing. Yeah, mainly, no, you can see Kafka implementation in big data systems, basically, where you need to connect different data sources. Like some may be relational data, some may be non-relational data, like unstructured data, right? So in those cases, Kafka is helpful. Same for data warehouses, like you can put a Kafka layer in between your sources and destinations, basically destination warehouse. And no, you can subscribe for for a particular topic, and then from that topic you can pull the data and then put it into the correct tables and all. So again, yeah, these are the mainly use scenarios for Kafka. So mostly if you see in industry, they use Kafka for any of this purpose. Okay, so I will share now three use cases link. I'll not go through that here in the class, but you can actually explore. There is one use case published by Netflix for their recommendation system, like how actually they are using recommendation Kafka in their recommendation system. Then Uber also is actually using tracking user data. And LinkedIn, yeah, LinkedIn is actually the creator of Kafka. Basically, they started building Kafka in their organization, and after some years, yeah, they open source the entire thing. So they also have published some good case studies, basically, how actually Kafka helped them to solve their business problem. Okay, so let's see what are the main parts of Kafka basically? Okay, so if you see Kafka as a messaging queue or messaging infrastructure, right? So inside, we have mainly four components in a Kafka system. Okay, first one is a broker, so which will handle all the requests from the client. Okay, so it can be the producers, or any other request. So it will handle everything, and in any Kafka pipeline, right? So you can actually have multiple brokers. So when you have multiple brokers, that is called a Kafka cluster. Okay, so in real time, obviously, one broker cannot handle so many requests, right? So because Kafka is used in huge to handle huge data, right? So we really need a cluster here. So cluster is nothing but a set of brokers, okay, and we can actually replicate the data within the cluster basically. Okay, and there is another component called zookeeper. I'll show you when I show the demo, like these two components. Basically, no, we need to start this broker or the server and the zookeeper. So zookeeper, you can imagine as a manager of those, like clusters. So zookeeper keeps track of all the state of the clusters, right? What and all are there, how many brokers are there, how many topics are there. Topics I will cover in the next slide. So how many users are connected, right? So all those things, zookeeper will help us to track basically. And producer or consumer, as the name says, producer is the system which sends some data to the broker basically. And the consumer is which will consume the records or consumes the data from the broker. So here, like for one producer, we may have multiple consumers. So that is the main advantage here. So multiple consumers can actually consume data in parallel. So that will help to improve the performance here. Okay, so high level, these are the four parts or four components like broker, zookeeper, producer, and consumer. So next thing is Kafka topic. Okay, so what is a topic here, right? So suppose the different producers, right? So they want to send different data, right? So they want to send different data to different recipients, basically different consumers, right? So how Kafka will differentiate between this data, right? So that is the main thing. Our main concept here is the concept of topic. Okay, so if you see here, right, so suppose system A, right, system A wants to send a particular data for, like that is a web event, right? So they have to create a topic basically in the Kafka. They are assigned broker, so they have to create a topic called web event, anything like topic name can be anything, and they have to send the data only to that topic. And the recipients or the consumers who wants that events to consume, right? So they have to subscribe to that topic basically. So they have to pull the data only from that topic. So topic is a differentiating factor here. Now if you see, topics are actually divided into number of partitions. If you see here, right, you can see partition 0, partition 1, partition 2, right? So what partitions allow you, actually it will allow you to parallelize a topic by splitting the data in a particular topic across multiple brokers basically. Okay, so you can keep this records in multiple brokers, and the consumers can actually read from any broker, any place. Okay, each partition can be placed on a separate machine also, okay, to allow for multiple consumers to read from a topic in parallel. Topic is nothing. If you consider topic name is topic is your suppose you have a folder. Okay, you have a folder in your Windows directory. So under the folder you will be having files, right? So suppose you assume that in that folder you want to keep only a particular file of a particular format, like text format. Each text format file will go to that topic. Like you have mentioned that folder name is web event. Now I want to get the data from web event. Okay, so in that case, I will subscribe to only that particular topic with the name web event. So I am interested only to get those text files basically. So whatever topic I am interested in, I will subscribe to that particular topic only. Pick here is web event. Now another topic may be anything else. So whoever is interested to in that topic, you can actually no get the data. Now inside topic you can see no this one, like if you see here, right, 0 1 2 3 4, right, those are, you can consider one record, one text files, so of similar format, but data might be different. Now each topic, right, so each topic you can put it in different partitions. Partition is nothing but a space here. So you can put each topic actually different brokers also. It is possible, like you can keep the partition 0, right, and partition 1 and partition 2 in 3 different machines. So how it will help is like suppose you have 100 consumers. So each consumer can actually read from different partitions. Okay. It is kind of a replica kind of stuff. So okay, even one broker fails, right, so you can actually manage that with these partitions. Okay, yeah. Each message within a partition has an identifier called offset. Okay, the offset is actually the ordering of the messages in a sequence basically. Right, so when you keep the messages, it will come in a sequence. So how Kafka put it, it's exactly same sequence the way it arrives. So it is last in, fast out. Okay, so 1 2 3 4, right, so it is actually maintaining that offset also. And consumer can can select, like from where it wants to read basically. If you want to read from a specific offset, no, it is allowed. Okay, so Kafka maintains actually something like this. Partitioning you can even you can visualize as a log. Okay, so we know, right, how the logging system works, right? So if you see Java log4j, for example, right, so it will print the logs in a sequence the way we added in our code, right? So the first log, the second log, the third log, it's like a you can very well relate to a logging data structure basically. Okay, so all the logs will be having a position, right? So this is first position, this is second position, this is third position, like that. So you can actually visualize a partition as a log. Data source actually write the messages to the log, and consumer reads the messages from the log at the point in in a specific time. For example, here maybe the data destination 1 it is reading from offset 4, and destination 2 reading from offset 7 based on their need. Okay, you can very well actually visualize the entire thing as a log here. The last message is the latest message basically. Here in this case, the 7th is the latest message for that particular topic in that particular partition. Okay, and Kafka, you can store messages. You can write your own retention policy, like how long you want to retain those messages. You can even implement something like, so suppose you are getting a real-time data, right? So you can maybe keep the data for a day, or a 2 days, 3 days, like that. You can write your own retention policy. If you see brokers, right, so each broker will be having a number of partitions, and each partitions can be either a leader or replica for a topic. So what is leader and replica is, like, leader means that is the main copy, replica means those are, you can consider as a backup copy. Okay, so suppose you have 3 partitions for a broker one. Now whatever partitions created first, right, so partition 1 will be leader. Now suppose something happens, and broker 1 partition 0 is partition 0 is no not responding or it is gone. So the replica copy will be considered as the leader. So who will do that? Basically, your zookeepers will do that. So that will maintain all those things, and it will update those things. I mean, as a consumer, you don't need to take care of that. This is all are is like processes, right? So this is a software component. You can partition can go down, partition can get corrupted. Suppose it got some data which is not good. Now you are not able to even read or write into that partition. So in that case, this replicas will help you to proceed. Zookeeper will help you to keep track of all the things. So it will take care.